Hello and welcome. I'm Bill Wake. We're here starting a new project. I'm calling it ROSY, and the idea is we want to draw circles, and we'd like to do circles in circles. I think Mike Hill inspired this problem, and Ron Jeffries has been writing it up lately. Follow him on Mastodon. You can see what he's been doing so far, or his website. But the idea is that little dot, the little red dot, we're going to roll the small circle inside the big circle and make some sort of rosette kind of thing. I didn't have the skill to draw that. If you vary the size or vary the shapes and so on, you'll get different kinds of pictures. There's the old toy Spirograph, trademark somebody, if you've ever seen that. We're after that kind of thing. All right. And I'm going to start a little simpler, of course. I'm going to start with trying to do this, draw that red point circling around. And I don't know if I can make a circle or it'll be a point tracing a circle, but we'll start there somehow. We're going to have a little bit of math. I'm trying to do this from more or less scratch mathematically, but I am not going to forget that I know about polar coordinates. Okay, so the idea of polar coordinates is, I should contrast. Cartesian coordinates are the x, y. So you've got a graph with two axes and you plot, X and then Y and so on. And there's a formula for how do you draw a circle in that. But there's much easier to think about things in terms of polar coordinates for circles. And the idea there is you specify a radius, R, and you specify an angle, theta, usually. And then you take the radius, which is usually that headed to the right kind of quadrant, and you go up by theta, the interval or angle of theta, and then at the end of the radius length, you draw that point. Okay, so that would draw there. Now, usually we talk about theta. Well, you sometimes think about circles with 360 degrees, but in math, it usually comes out easier if you think about them as 0 to 2 pi. And that has to do with the fact of pi being the kind of ratio of diameter to circle. And with those in place, you can pretty well specify circles much easier. And I think that's what we're going to do. Then the other one we can do is you can convert them to Cartesian coordinates, which is good because that's what all the graphic tools use usually. And it's just r cosine theta is x and r sine theta is y. Based on, the definition of cosine and sine, that's kind of what it means to be the cosine. And that assumes you're doing the radians 0 to 2 pi thing. We are going to try something a little different. I heard about using 0 to 1 as sort of the proportion by which you're around the circle, starting at that horizontal line on the right of the circle, and then wrapping around it as the number gets bigger. All right, and then there's another idea of moving point. Whoops. There's the circle it traces. Okay. And then moving points, if you have x, y, and you want to move by some distance dx, dy, then basically you just add them. So x prime is x plus dx, and y prime is y plus dy. And that moves something from one place to the next. All right. Okay. Well, what I've got so far is an empty project. Here's an empty test that does nothing. And I put in, assets. I gave it an icon. I don't know. Just doing that always makes me feel like, oh, it's turning real. But as it is now, it's just a bare app. I think I've deleted comments or whatever, but just took what it does out of the box, which is put a little symbol up and say, hello world. Now, let's find the content view. That's the thing driving that. Okay, so here's system image globe, large, and the text, and then some padding, and that's the deal. We have this preview mode, and I probably should be using it more than I do, so we'll do that. I'm going to write this mostly as sort of a spike. I'm mostly interested in how does the math play out, and not so much caring about am I going to turn this into some sort of production app. So I'll do most of the stuff as a spike. I might write a test here or there just to kind of make sure I'm not going too far in the weeds on some function. But in general, I think we'll treat it like that. Okay, so hello world, and it gets stretched into the full screen and when it's placed in its full view in the app view. Okay, all right, close this. Let me get my to-do list out here. And is that showing up? It is not. Okay. So Rosie, we're going to try and start with a circle. Then we'll put a circle in the circle. And then I bounced around a little bit looking for Swift UI things that looked useful. One is unit point. It basically says take your whatever area you're talking about and treat the scope of it as 0 to 1 in both X and Y. So if you're going to use it, you're going to have to scale it back out to get to the actual coordinate system of the screen. But for most things inside there, it sounds like, that might be a nice way to do it. I mentioned already doing the proportion 0 to 1 on the circle, so that'll tie in. Let's skip around. Timeline view is a view that basically it calls you, you can tell it, I want to do animation, and it just calls you as some sustainable rate, probably 60 frames a second, I would guess, something on that order. And gives you the clock when it's called, so you can work that out. And canvas represents a kind of a drawing area, and then path is a shape that you could fill it, you could draw it, you could stroke to get the outline of it. I don't know that we'll need these. I ran across them, so I'm not a deep graphic programmer by any stretch, so we'll go from there. All right, so content view. Well, one thing I know I want is we want to put this thing in a frame that's of some size. So let's do, 500, 500 width and height. And, okay. That'll define a bigger square for us to work in. And I think, let's see, I'm going to try, well, let's put all this in a timeline view and just see how that goes. Timeline view. And then we can tell it animation says call me a lot. Timeline in. Okay, and so it will call this repeatedly. I'm not quite sure about. Well, let's just see what it'll tell us. We can get the date, the rate. I don't know what type that cadence is. Okay, let's do that. Let's just put text with timeline dot date. Okay. Oh, there we go. Oh, notice it's updating 58, 59, 109. Okay. So it is giving us that information. That's good. And then, I don't know, I don't know if this, can we put a print in here? I don't know. May not build. Yeah, okay. There's a way to do this, but I don't know it. We're getting it every second an update every second. I don't know what that will be. What was the other thing? Cadence? You don't like that, huh? Okay, I guess we don't know how to convert it to a string. Okay. Well, that's a start. I don't think we'll need this then. Envelope formatting. Okay. I'm finding that a little annoying as it's flickering there. All right. Let's take that out. Now I don't know if you just draw hello. Okay. I don't know if it's really updating every time or not in this case. Before I could see it because of the date. I have the feeling it redraws its thing every time it's presented. Okay, so let's get that notion of this dot moving around, and the natural way is counterclockwise. I think in our application we actually like to go clockwise. I don't know if it really matters. I don't know if. Okay, well, one thing I know we can do is we can put this whole thing in a canvas, which gives us more flexibility for drawing. And a canvas gives you a context, which is the thing you draw into, and it gives you a size. Let's put that down here. Okay, and doesn't context size in. Result of text is unused. Yeah, this canvas is more. How should I say it? In Swift UI, you have these elements like text that are they're true elements that sit there on the screen. Canvas is more one that says, in your space, here's some code that does some stuff. Okay, so I'm gonna try just kind of a simple thing. I'm not sure. Okay, let's just. I'm gonna let x equals 250. Let y equal 250. I'm just gonna try and get something drawing here. I know you can say context.draw image. Well, maybe we should take a look for images. I never can get that on the first key press. Let's find some sort of dot. I'd ideally like one that's centered in its place. Oh, yeah, that one's probably it. A middle dot. Okay. I guess I'm looking in the wrong place. It takes an image. The easiest way to get that is from this San Francisco symbols thing. Now, I don't know what he has. Dot square. You think a simple little dot would be just fine. Okay. Maybe we can try circle. Circle.fill. Okay, let's try that one. Let's see. That would be image system name circle.fill. And we'll draw it at I think this is the way you do it. CG point X Y Y. Let's close this. Hey, there's a dot. Okay. Let's put another one. Okay, that's something. Okay, let's put this in a loop. All right, I don't need two dots for that purpose. Draw X. Let's draw I. Okay. That seems promising. All right. I mean, we're getting stuff drawing on the screen. I don't know that I know what I'm doing super well. This looks fat to me, and I don't know. Let's pull it out. Image. Okay. And there's no reason to do that in the loop, so let's put it out. And then dot scale effect. Wow. Cannot convert some view to specify. Oh. No, image. This is image dot scale effect. I mean, you proposed it. I'm not sure why you're objecting to it. 5. I might need the word scale there. No. Cannot convert value of some image. Oh, I guess. Okay. The deal is, theoretically, that lookup could fail, and we don't want that. No. Cannot convert image. Some view to specified image. Okay, you're happy with that, huh? Good. Oh, what's the result of scale effect? Oh, yeah, it's a view. Okay. Draw is happy with an image. Okay, well, let's start there. I guess I'm moving away from what I care about. Now we've got the timeline view. I shouldn't need to loop, maybe? Okay. I wonder if I can capture that first time? Let's see what timeline.date has type. Date. Dot. Date. Formatted. I don't want to do that. Is it datetime.now? I don't know. Is there some language in which it is? I'm absolutely sure that's true. Let's see. Date. Oh. Okay. So if I take the date, let's see, this is just straight up code. So I can say let delta, is that normal name? Delta is change in time, equal timeline dot date. Do I do minus? I want to compare. None of these looks good to me. Description time interval since 1970. That's good. Let's do this. Dot time interval since 1970. And then time interval since 1970 minus start. Okay, and we'll print start delta. All right, we'll do it up here. I'll just inline this. Okay, that's cranking along, and I can see by the blur there's a lot of numbers going by. Okay, so I don't have to print it anymore. All right, so this should give me a delta. And then I imagine there's a way from Swift double fraction. Can I just get the fraction? I don't want to divide if I can just call something. Yeah, really, I'd rather just have the documentation for double. Thank you. Constants, no. I don't want the binary. Oh, come on. You think the fraction will be a very simple thing to ask for. Did I miss it up there? I don't think I can do modulo. I suppose I could take the remainder dividing by 1. No, would that work? Yeah, maybe. Okay. Right. Let's see. So what I'm trying to do is I want to get this into 0 to 1s because that's my proportions I want to do. So okay, let remainder equals delta dot remainder dividing by is this gonna work? 1.0? Kind of don't think so. Oh, are we okay? All right. Now let's Let's make this a fraction. And let's take size dot x is width and see if we can trigger this. No. Int. Let me take this out of it. Let's let I equal remainder. I got one too many. Whoa, there's something. Okay. 0 to 1 is that appears to be going to the center. It is increasing and it is pretty fast. Okay. So X and Y have nothing to do with this anymore, right? Okay. Why are you... Let's print delta. I think we can do that. I'm feeling like it's either the scaling I'm doing or something is funny. That it's only going... I can believe 0, 0 is the top left because I think that's sort of the default on these views. But this print should be working. Why are you not printing? Well, let's run it and see what happens. Oh yeah, there we go. Oh yeah, my division is very wrong. Okay. Yeah. All right. So this is a good place for me to write a function. Okay. So let's do that. Function fraction part. Fraction. It takes a double and it returns a double. Now, I'm not quite sure why it's working. Let's put it in the way it is. We'll just return d dot remainder dividing by 1. Okay, 5.2 divided by 1 is 5. I don't know if that gets the remainder. All right, let's use the function fraction of delta. So I'm getting it in place before I fix it. Okay. We'll stop the run. Okay. Get this out of the way. Alrighty. That animation is really distracting to me. Okay, so fraction. What are we doing? So if we take a value divided by 1, you get the value back. So there's no use in that. I keep thinking there's got to be a way to do this. Remainder. Well, maybe something like this. Remainder of this value divided by the given using truncating division. Okay. Let's do that. Let int part equal d dot what's the significand? No. What do we call that? Form remainder? Replaces, returns. Remainder, no, truncating remainder. Divided by 1.0. Okay. And then return d minus int part. Okay. That works for positive numbers. Preview paused. Well, okay. I mentioned I might do some testing along the way. This is one of those times. Well, maybe I should just do a little debugging. Oh, there's D. Did I hit the wrong one? Let's continue. Print D, step over. .216, and then D minus int part. That's going to be fine. Okay. Can I add a conditional? I think. Condition D greater than 1. Okay. Let's continue. This, I don't know. I see that sometimes when I'm running things. It doesn't appear to be anything we're doing. Print D. 90. Okay. Step over. Int part is 0.29. Oh, wait. Int part is truncating remainder. Oh, that's the part we want. Okay, let's just return that. We still got a bunch of prints. Let's take this off and continue. There we go. Now the frame of this thing, see if we can catch where it's coming out. Somewhere there to somewhere on the bottom. I think if we put a color on this, background light gray. Background color. Oh, come on. There's too many of these. Oh, color dot. Oh, jeez. Really? How about yellow? A little ugly, but I just want to see where we're looking at here. Just to convince myself, yeah, this thing is only that. Okay, I don't need that. Well, that's going. All right. I don't know. This is looking kind of slow. All right. Alrighty. So now let's start applying our circularity kind of thing. Okay, so I got remainder is fraction of delta. Let's call that proportion. Okay. And okay, so what I want proportion to be is the angle on that thing. So I'm going to assume I'm at the center. And the nice thing about this unit point idea is I can talk about the center very easily. Okay, so let center equal unit point dot center. All right, and let radius equal 100. Okay, and then well, I think I can do this outside even. Image equals that. Okay, I is proportion. Okay, so I've got my radius, my center, and my proportion. So I should be able to place this point. Okay, so let's define a little function for that. Func point for well, let's call it R is a double. I'll call it P for proportion is a double, and center is a unit point, and it's going to return. I guess it's going to return a CG point. Is it? I think maybe he returns an X and a Y. Double. I'm trying to save that translation out from unit points back to later on. Okay. Let's just return Center dot X, center dot Y. Okay. Okay. And I don't care about I anymore. What I want to draw is point dot X, point dot 0 is X, and point dot 1 is Y. Okay. I don't see anything changing, which seems very unlikely. Paused. Okay. Let's try again. Okay, let's break here. Oh, well, radius 100 is way off base, because this has to be in units of 0 to 1. So let's do 15%. Okay, so if we take, center.x. Okay, I didn't do the work. All right. But we do have to keep the radius in 0 to 1 range. Okay, so now we just have center x, center y. All right, let's stop that. Okay, so given this formula, x equals r cosine theta, y equals r sine theta, we need to get that thing converted. Okay, so let's take x is r times cosine of p times 2 times, I don't know where pi is, double dot pi. Okay. Let x equal this. Let y equal that. Okay. Oh, we didn't add our center in. Plus center.x plus center.y. Okay, it's slower than I wanted. Maybe it works. All right. Okay, what I think is going on then is we're given Well, with the timeline view, we're only given that moment in time, and so we get the one dot. But I don't know. Is it too weird to accumulate all the dots? It may be a lot of dots. All right, and let's do some varying just to kind of see how it looks. Okay, there's 35%. Okay, and then I guess we shouldn't go above 50. Boing, boing, boing. I need sound effects too. Okay. And 0.05. Okay. All right. That gives us coordinates these are unit point coordinates. Okay, so maybe let's see what unit point is. Is it a CG point? Then we can just use it directly down there. It's not. It's its own thing. See if it has anything to convert back to CG points. Not really. Okay. Okay, so, I'm resisting doing this. I think Timeline View draws every time from scratch, and so we're not, what we stay around draw doesn't stay persisted. I don't know if there's a way to change that. Okay. But I think what we're saying is the proportion seems okay. All right. And then I guess, do we accumulate? Well, the center, let's say the radius and the center aren't changing really. So it's really these proportions. Okay, and they are double time interval. Time interval. Well, fraction delta. I think that's a little weird. Proportion. I didn't make it. I mean, proportion says fractions producing a double. Okay. Alrighty. So what I'm gonna do is, I'm not sure if this is the right thing to use, but, what would we call these? Proportions is array of double. Okay, and starts out empty. Okay, so if what we do is when we get a delta, let's add that proportion to that list. Okay. Now these I'm saying are fixed. Okay. And then we're going to have to do a loop over all of them. Proportions dot for each. Point equals radius p is $0, which is the proportion. Hey, look at that. Okay, let's make this a little bigger. Yeah, he's continuing to draw. Now, interestingly, he seems to. It's taken him a while to fill in those holes. Okay, but he's working on it. Probably some. I don't know. Maybe there's some way to do a timeline that's tighter. But it's a start. I'm okay. Would that pay off? I guess I want to wait till it happens. But and I don't like the thickness still. Okay. All right, let's see what else we can do with timeline. Timeline schedule. Okay. Periodic. I don't know if that's gonna start date. 3.0 is seconds, I think. Yeah. Okay, let's try something like this. By 3. Okay, that says every 3 seconds. What did I call it? Start. Wrong type? Yeah. Can't do that. Yeah. Okay, it's every 3 seconds. Let's. It doesn't seem like every 3 seconds. Let's do 10 seconds. 1. No, it's not doing what I thought. All right. I don't know. No, I think that animation was getting us about as good as it could do. What that false start is. Okay. And let's just try another value. Okay. Let's see. Now, I'm accumulating bazillions of these date timestamps. All right. So 1 hour in, we can draw a circle. It's a little bumpy, but it's a circle. The good thing is we're using our proportion. Basically, we're taking the seconds, whatever fraction of a second this thing tells us it's giving us. We're doing those. And we're letting them control the circle. So in principle, if this thing was drawing 60 points a second, it would basically it would draw the whole circle in a second. I don't know if we can we see that the first time? That might have been a second. Okay, I buy it. All right. Now, well, there's a couple ways I want to go. One is I'd like to get into the circle in a circle thing because that seems more interesting to me. But the other is I'm a little worried about the quality of our circle, a little worried about the time of it, and I'm a little worried about accumulating 8 gazillion points to draw the circle. All right. Well, we're due for a break. So let's take a 3 to 4 minute break and we'll come back and see if we can get this thing drawing circles in circles and get the rosettes that we're after. And then that leaves us the rest of today and tomorrow to worry about these other issues. But I like this so far. We feed in a fraction that's a proportion is just the portion of a second and map that to the portion of the radius or radius going clockwise. And then we use the simple conversion that we defined. So we did r cosine, basically radians, p times 2 pi is radians. And then we translated by the center position, by the center. Okay. And that part leaves this very clean to me, that proportion is a simple number. Center and radius seem to be the bare minimum you could say to be a circle. And then somebody's giving us a point at this given time. Okay. So I'm okay. All right. Well, let's take that break. See you in a few minutes. Basically top of the hour. Bye-bye. Hi, welcome back. All right. So we'd like to, what we want to do is take the center of this circle and really trace it around another circle. So a smaller one for this is probably called for. And so we're moving the center, and as we move the center, we're also spinning the circle and making it do the right thing. But I think the big thing to see is if we rotate this as we're moving this, it's really the center of this circle is tracing out sort of an inner circle here. And that circle is this distance minus the the center of the big circle minus the center of the little one gives us the radius of the circle that we're tracking out, if that makes sense. Okay. And the other thing I see is this little mess down here. I'd like to make that easier too. So let me define another function. This one is I don't know, I'm going to call it screen coordinates of point double, and it's going to convert it to a CG point, which is the thing we need for screen. Okay, so I want to take this screen coordinates. Well, let's just take that. Oh, and a size. Something. I don't know what that type is. CG size. Okay. So this is point.0.1 size dot width size dot height. Okay, that sounds right. And okay, that's cool. All right, now this is, I'm not sure how to stack these up. I mean, ideally we'd like to be able to put circles inside of circles inside of circles and stuff like that. But I think what I want to happen is instead of just tracking the proportion, I'm going to have to know the center as well, because it's not going to stay locked in on unit point dot center anymore, the center of the screen. It's some other process is moving it as well. Okay, so I think what it means is I want to define a structure for the whole circle. No, for the, it's got to be those those three things. I don't know the right name for it, but it's a circle of some sort, but it's really a pen circle, marked circle, marked circle. I can live with that. Pen circle. Pen circle. Maybe pen circle. Let's define it and see how we feel. Pen circle. Okay, and it's got some information in it. Basically these three blips of things. A proportion, a unit point for center, and a size for radius. Okay, so let's define R. R is a double. P is a double. That's our proportion. And center is a unit point. Okay. I don't know what's going on here with this. I keep seeing this thing go double start. But anyway. Okay. And let's move this down. I'm going to fill in those things first and then change what this holds. Okay, so proportion. Okay, let's make a pen circle. Pen circle. R is radius. P is proportion, and center is unit point dot center. Okay, and I think here we can just inline this, and that's inlined, and then this. Okay, we'll inline that in a minute, but let's put these in our thing instead of just doubles. Pen circle. Okay, and then here. Proportions for each. Now this is $0.P, $0.R, and $0.center. There he goes. Okay. Good. All right, now proportion doesn't show up anymore, so we can inline this. And these are no longer needed. Okay, now let's see. Well, maybe this is the guy that's got to change. Unit point dot center. Make my head spin a little here. Okay, so what I want to happen then is every moment the proportion should also adjust the center of the circle around around the home. So we need a radius. We need the overall radius. Okay, so let's do that. Well, how about outer? Outer radius, let's make it 0.4. Okay, so it'll be 40% of the screen. And then the inner radius, let's put that here. Oops. No. Okay. Inner radius. All right, now we're going to have to do something like the same calculation. I'm trying to say that the position of the overall circle is a function of the current proportion. I don't know if I'm killing myself with these intervals or not, but all right. Let's so where's that going to be? Okay, so outer radius 0.4, radius 0.1. Okay, so outer radius all right, okay, so this is going to move the center. Okay, unit point dot center is not right. That's the center of the big circle. But let's make this inner circle. Sounds more mysterious than it is. All right, let outer circle is, well, I think he's also a pen circle. His radius is outer radius. His proportion is, well, let's calculate that up somewhere here. This is the thing that's interesting to us from delta. I think we could probably encapsulate that too. The radius is outer radius. The proportion is, no, this is not right. Okay, the circle is going to be outer radius minus inner radius. I think we already, let's see. So there, outer radius. Yeah. So it's trying to get to the center. So this radius, so the big radius center minus that should give us that. Okay, minus inner radius. The proportion is still proportion. And then the center is unit point dot center. Okay. That's the traversal circle we care about. Okay, now the center is really I guess it's point of this stuff. Where's point called? Point of all that. Well, that should just be point of a pen circle. All right, let's make a point of a pen circle. Okay, so we're just going to pull everything from circle. Circle piece, circle center. Okay. That should be okay. We should still get our old circle, yeah. All right. Now, let's substitute this point in for, this should be inner circle. Is that going to be right? Okay. But now each inner circle, when you add it in, his center should be outer circle center. No. His center should be outer circle's point. Point of outer circle is double. Center was a unit point. Oh dear. Let's convert this to a unit point. Well, it'll tell me in a moment. I think. Screen coordinates needs to take a unit point. No. Okay. Oh, I think we're getting the outer circle is what it seems to be. We're not rotating something, I think. Okay. What if we drew the inner circle and the outer circle? Cannot count value of non-function point. Oh, that's... I think I'm overloading point and it's confusing it. Okay, something's going on. So that's the inner circle. It's like he's got his pen locked at the outside, doesn't it? Well, we could see it sweeping around and filling it in. I don't know. Okay. I guess at every point here, I could print this point. And what am I seeing? I guess I'm seeing... Maybe it's a rate thing. Because I've got these two synchronized at a rate. Let's take... Okay, let's make this... So I think what's happening is my circle is moving in precise coordination with my inner circle, and so it's as if it's turning the thing as it draws to make it kind of stick straight out from the inner dot going around, because they're both synchronized. So what I want to do is let's take... Let's make this proportion be... What if we divide? There we go. Oh, yeah. Hey. I like it. Okay, let's change some numbers. Okay, we're getting 4 rosettes. Is that a function of... Let's make it 0.3. Right, is that a function of this? Now we're filling in. I don't know if it's making it better or not better. I guess something's emerging there. I don't know, the precision on this is just not high enough. Yeah, that's going to take quite a few passes to resolve, but it is resolving. I mean, that's very plausible. 3, 5, 7, 9. So I don't know. It seems like dividing by 10 gives us 9, and divided by 4 gave us 3. So I don't know. 5 gave us 4. And we did not append that little dot to the points. Well, I call them proportions, but we should rename that. Maybe dot array. Don't know. I do think I want to use here's circle. Okay. Well, I mean, it's filling in a few more passes, and I think you'd say it's pretty well defined. Whether it will necessarily fill those in, I'm not sure. But it's coming. Yeah, a little bit each time. It's just whatever little jitter off, it's got as it computes these things. Okay, let's really up it. I don't think we're going to see that emerge. It's going to be slow. Okay, a minute, 40 seconds each time, basically. Okay. Well. So I think it's doing what it should be doing. I mean, that's definitely what I expected it to do for shapes. Draw those little rosette things. That's why I call it rosy. But the quantity of points, I mean, I'm using these giant dots, which is probably no big help to anybody. Who was it? Was it Dave? I have to. I just hate Twitter anymore. Who gave me? We had some discussion around this, and I don't know. Was it in here? No, I think it must have been in Twitter. I'm gonna have to. Let's see. Oh, maybe it was Jeff. Had a couple suggestions. No, somebody else too. I'm sorry. I've lost my phone too. So, one of the suggestions I got was like, hey, what if you, instead of just drawing individual points, you did line segments from point to point? And like, yeah, we can do that, but it's kind of clunky. We have to keep track of more state to do it. It's not a ton more state. It's really like, what's the last one? So my laziness is going to come out here. Now, one way to do it is it's adjacent pairs. Okay. I know this is Swift adjacent pairs. I think it's one of their new algorithms. I may have to say import algorithms. Yeah. Okay, let's try that. They've got a bunch of packages coming, or they define a bunch of functions in this algorithms package that they maybe will migrate in someday. Adjacent pairs. Dot for each inner circle. Oh no. It's old, new, in. Okay. Now this one goes away. I guess it's not complaining. That's a good sign so far. Oops. No such module algorithms. Oh, what do I have to do? Let's see. Package dependencies. Can I add algorithms here? There it is. Pulling in a lot more than I want, I guess, but we'll find places to use it. Okay, so now that should go away. All right, so down here, property add test called, yes, okay. Okay, I guess it's an extension of sequence. Okay, so we have a sequence, we do this, we get old and new, and now we want to draw P1 equals point of inner circle. Okay, I'm going to take this one out. We lost our memory now. What's going on? Oh, I don't have... Well, no, I don't know. Dots for each. Okay, P1 is point of inner circle. Well, this is now old. No, yeah, old. No, context dot draw. Text dot. Is it stroke? Okay. I don't want to, I just want to draw 2 points. Image screen coordinates. I don't even want to do image. I just want to draw a connecting line. Path. No, that doesn't sound right. Okay, what is context? Let's spike that. Context. Okay, you're not happy. Graphics context. stroke, but I don't have a path. Draw in. That's a symbol. That's something different. And a different layer of graphics. Nope. Well, let's try this. Swift UI draw a line. Well, okay, yeah, I can create a path with a rectangle, but I don't want to do that. Can I? Okay, well, I guess maybe we can do this sort of thing. Whoops. Path. Point and size. Oh, it's a CG point. Well, let's try P1. That draw, no, stroke, add line. I don't think it's gonna like my UI unit points there. And I don't know if this is required, but path in and fill. Oh, that's actually doing the, I don't know if we need that fill. Cannot convert unit point to CG point. Well, that's doing okay-ish. Am I doing? No, I'm still drawing my dots. Okay. Now, well, they don't do the stroke. They just do a fill. Let's try this one. Context of path. Let's see what it suggests. with shading. Stroke. No. Okay, I could say color. Keep that green idea. Dot color. I really could use an example with shading. Do I have to say graphics content? Gotta spell it right even. Okay, now we got dots coming there. Let's see what happens. Ooh. I think you're talking here. Okay, I'm gonna go find my phone. Well, I will say dots probably were easier, but these segments are looking a ton better. All right. Yes, it was Jeff Grigg. Okay, cool. Yes, thank you, Jeff. All right, so this is my giant spirograph with 100 or 99. We'll let that finish, but I'm really happy with it. I'm not sure my color choices are award-winning. Okay, fine. Let's see. Well, I probably could make my color this. Let's see. How do you get to the accent color? We have that value. I think I can just say that in quotes. Color. Yeah. All right. And then this. Well, this might look better as yellow. Let's take a smaller number here. Let's do 25. All right. Now I'm going to take that point off. We're not going to draw the dot anymore. And just do the spirals. Okay. Cool. All right. Okay, good, good, good. And I don't know. We'll do the deeper one and maybe change the radius to 0.2. I don't know what that'll do. The other thing I wonder is if you, well, that does the whole thing around the center, right? Exactly at the center. It probably makes sense to be as big as the center. I don't know if it makes sense to be bigger. Well, that's a neat shape. Holding my hand so I don't mess it up before it finishes, because I think it's looking pretty good. All right, that's a nice enough shape. Okay, now we're refining a little bit. Okay. Well, let's see. What will make things good? Okay, I've got to do. I should probably let's organize ourselves a little bit here. We've got ROSY-23-01 and we start with a circle. We put a circle in a circle. This is just kind of information. Okay, we ended up using Path and Canvas and Timeline View. Okay, all the stuff I ran across and reading about it came true. Alrighty. What should be next? Well, I think you could easily you could add the sliders for these things so that you redraw them, and that would be something. That I mean they're interesting. Okay, let's try inner radius bigger than outer radius. Bigger than half. It's going to be a little awkward, I think, but interesting. Okay. Yeah, those line segments, you can see their bumpiness at this level. And let's go much bigger. It's too big for the whole screen, so. Yeah, I don't think we can see what happens there. I guess if we could do this 0.2, 0.4. I mean, you're getting something. It's not unbearable. Okay. It's out of screen range, but okay. Alrighty. Well, We could parameterize these, inner radius, outer radius, and time. I guess kind of the rate of spin or something like that. So that's one idea. We'll accumulate a few. Okay, so parameterize by inner and outer radius and spin ratio, spin speed. I think I would really like to do, I mean, I don't think this is unbearable. It's a little awkward. Let's see. Well, the thing I don't think you get is this relationship. I don't know. That's it's a little hard to see them. I mean, I'd kind of like to say stack these things, right? And then I don't know. It feels implicit, and I'd like to make it implicit, I guess, is what I'm getting to. And all right, and let's make 0.45, inner radius 0.1. I think we'll get a nice looking spiral. They look a little better when they're overcrowded though, don't they? Okay, let's do 20. Yeah, then they overlap a little. I think that's nicer. Okay, and maybe 15. Now, that's one revolution of our inner thing. It's still going. You can see down the bottom a little bit of a divergence there, as it picks different points and the line segments don't quite overlap. I think in enough time they would round out, but honestly, I think once you've done it once, you really don't need to do it anymore. And that's really a function of that delta divided by 20. So kind of 20 steps. Yeah, I mean, once it gets around, I guess that's 20 seconds, right? Because we made this draw in 1 second, so it's drawing at 1/20th the speed there. But after that, I don't think there's any advantage to filling in a bunch more. I don't know. Maybe it'll smooth out long enough if I let it run long enough. But okay. So this to me is really draw dots. Let's see if we can extract that. Okay. Size, context, and that relies on this having access to dots, which I think that's the only thing it has. So let's just pass it in. Dots is array of pen circle, right? And then I think I'm gonna, well, size is size and context is context. That's not too bad to understand. All right, but we have to pass in dots. Okay, now these really do need to be parameterized. Okay. I want to somehow, I want the notion that I'm putting a circle inside a circle. And if I can do that, I can put a circle inside another circle too. So that's, yeah, I think the difference is, pen circle, I'm not really hooking them together, right? I'm taking a numeric value that's derived from this one and putting it to that one, but I should have some sort of structure that knows that and makes its center. Okay, so what would that look like? I guess I'm feeding in one delta. Proportion is just delta, fraction of delta. Okay. Given delta, well, this thing, yeah, what I'm wanting to do is define some structure that ties these two circles together. So I want to take a circle description and I want to chain them. And I think that means I'm getting a center. So, all right, let's make a structure. Getting a little beyond one object here. All right, well, let's define pen circle. Let's define a cycle. And it's not the pen circle that matters. Like somehow, so I want values to feed through, and I want to give it, let's try enum. Sometimes we have these indirect enums in Swift. Cycle. All right. And what can they be? Well, they can be a this or a that or a thing that contains itself. And I think what we're saying is I've got Okay, so one case is like the innermost circle is just a dot at the unit point. Let's call it, I don't know, absolute center cycle is either a point or it's a well, what is it? It's a thing of a radius. We don't want the proportion in there because that's dynamic, but the radius for a given circle is fixed and the center is fixed relative to that circle. That tells me my points. Maybe I shouldn't be tracking the circles. I don't know. Maybe this is the thing I was missing. I'm going to say it's a cycle, and a cycle has it's got a radius which is a double, and it's got a center which is, I think, a cycle. Is that the right stuff? Okay, so P is irrelevant. Those are constants. Center comes from there, and it's got the radius. All right. Now, given this, how do you draw it? Well, no, it's also got to have a drawing ratio, a speed. All right, let's use some type aliases here. Speed equals double. And let's do radius. Okay, let's see. I should take a snapshot of that and post that. Is 20 a good one? That's good enough. All right. Okay, and let's post that. I'll bring in Ron specifically. And was that 25? 20. Okay. Oh, focal point. I guess that's probably okay. That's probably better. All right. Not sensitive. Okay, I guess I could tweet that too since I had suggestions. Oops. Okay. So we've got the basics. Now we're trying to get this thing going. So this is radius. Okay, so I think I'm saying, if you get a cycle with a radius, a speed, and an inner cycle, and at the innermost one, you're going to have a point. Maybe it's absolute center. I think I can let it be implicitly in the center and not mess myself up too much. Okay. Then what you do... which way are these going? Inner to outer? I think so. You meant to go down and back out to calculate it. Okay. Right. This is probably about the time I should be using some testing with this, but I'm just going to wing it a little tomorrow and see what happens. All right. So the representation I have is you've got a center, sort of the absolute center, and then you put a cycle around it, like we put the outer circle around it. And then you put an outer circle around that for the innermost circle. I'm sorry. Maybe a circle inside. You got the center. You put a circle around it. You put a circle inside that. You can put a circle inside that. And you give it a speed. So you're not... well, when we had both 1, it just drew the big circle. Okay, but if they're a ratio, then that helps. And then that cycle. Okay, so now the question is, given that structure and this structure, well, where's my main? Okay. In here, you're given a proportion. No, you're given a delta. And we have to calculate the center first, then the outer circle, because that's our center for this one. Okay, so I guess the question is, how do you find an inner circle? I don't think that's the right thing to append. Do we care about the circle? What are we pulling from it? Point. I mean, the point seems like what I could put in that list. Right? That seems like what this thing should have. So let's put points. Let's move this code into the circle. Yeah, so I want the points to be calculated. I want those to be what we append. Okay, so let's commit. We haven't done much of that. All right, so what we have is rosettes with outer and inner circle. And I've got this up on GitHub somewhere. All right, now I want to transform this to being point. So unit point. Oh, do we ever call this one now? Nope. Okay, so unit point. Where's your... unit point. Okay, someone should complain. Oh, down there. Okay. Point. Let's see, that should be in here. Let's append point of inner circle. Okay. Dots needs to be unit point. And then old and new are both points now, so this should go away. Old. Old and new. Is that going to do it? Okay, I'm going to put a faster number in here just so we can... all right, slightly faster. I still want something interesting, and this seems to be the least. I mean, that lets it overlap a little bit. Okay. Now, let's save that. Be a little more diligent here. Make dots hold unit point instead of pen circle. Okay. Now, I want this thing. All of this goes to computing point of inner circle. All right. And point of outer circle. So the function I want is given a cycle, whatever that means. I want to get a point out of it. It's point at or for proportion. Okay, so let's give this thing a function. Point for, well, let's just say proportion. Proportion is a double. Produces a unit point. Okay. So I think given down here, given, do I want, maybe I need delta. Is it time interval? Okay, let's do that. I want you give me a time interval for a given cycle, and I will tell you what his point is. Okay. Well, there's two cases. Switch self case absolute center, and we're going to return unit point dot center. And then there's a case for cycle, we're going to take radius, speed, and inner. Whoops. Okay, that's more complicated. All right, but I think what we've done. Yeah. Okay. For the outer circle, I think we have to configure it with the inner radius, outer radius. Okay, so I think let's do this. Let r equal radius. And next is P is the fraction of delta divided by its time scale. Let's say speed. Let P equals delta divided by time speed. And this should be the fraction of delta divided by speed. We'll have to pull that up. I'll just pull it to a free function for the moment. Okay. And the center is, I think it's inner dot center. Okay, I'm going to do this kind of as a parallel change. Inner dot point. I don't know. Point delta. Is that going to work? All right. So that would give me if I take a point of inner circle of that. Sorry, inner circle is pen circle with that stuff. I think we can make this easier, but let circle, pen circle of this stuff, R, P, center, and then return I think it's point of that. I don't know. And point, again, I'm going to pull it up. It's not, it really belongs on pen circle, doesn't it? R times cosine of P times this circle. Delete all the circle dots. Okay. Point of circle. circle dot point. Okay. Oh, how we feeling there? Somebody's unhappy. That's outer circle dot point. Okay. All right. I don't know. I'm catching something there, but I'm not catching the whole thing. Because somehow you have to... Let's see. The structure is going to be... unit point is the first thing created. Then the next circle. Then the next circle. Okay. So... You're doing the inner... Center is the inner point. Okay. All right. So now let's set it up. We haven't used cycle yet, so let's make one. Timeline view can let's make one. Well, we can make it here. Let big circle equals cycle dot, let's say dot cycle. Radius, speed, and cycle. Okay. That's outer circle. This is outer radius minus inner radius. Speed 15. And the cycle is dot absolute center. Okay, so I think that's the description of this. All right, and then what inner circle? Well, let's call this outer, and inner is a cycle with. Radius is inner radius. Speed is 1. Cycle is outer. Okay. Now, excuse me. So if I take inner and I ask him for his point at delta, inner dot point of delta. Excuse me. All right. Now that should be the same type as inner circle dot point, unit point. All right, let's sorry, excuse me. Okay, I think we're working. Now, is anybody looking at inner circle? No references. Okay, I don't think anybody's looking at any of these now. Okay. I'm going to inline this. Now, this can definitely be set up outside somewhere, but I think that describes... Okay, the outer circle is a cycle around outer radius minus inner radius, so it's that sort of centerpiece point. The one we had circling independently at first. Inner, outer, those... Let's... Well, it's messy to try and get it into a global or into a field up here. Let's see. What can I do? I don't need this anymore. All right. But notice nothing in the loop cares about this. All this stuff is, these two is set up. Actually, these two as well. But that's all set up for this thing. So I'd like to create these objects. I'd like to pass these objects in, honestly. Right? And then the computation is really figuring out delta and then asking this cycle for its point. All right. Well, that's a good place to pick up tomorrow then. All right. So what we did was we changed, we added an enum structure to represent the nested circles. Okay. That's fine. I still haven't parameterized. But what I want to do is pass in the cycle to the view. Okay, so I'm starting to break up the view a little more, make it a little more realistic, I guess. But I think that's a good place to pick up tomorrow. All right. And I can see pen circle going away. I don't think it's adding much. The only thing it's adding is this computation right there from the circle to the point. And it's kind of not quite a one-liner, but it's pretty straightforward. It kind of is the transformation we're after. This is a little different, but I think that encapsulates it. Okay, so then the one thing I want to do is let's add level 3. Really inner cycle is cycle with 0.1 and let's do 0.5 and inner. I don't know. Do we get our little epicycles things? I'm doing inner dot point. I need to do really inner. Okay, this is promising. I'm getting that extra little wiggle in there. So this is epicycles, right? If you ever hear about, Galileo and all the stuff around that, and they were doing more and more levels of cycles to try and more closely approximate the way these things get done. I don't know if this will be even more. I probably should. Well, interesting, but I'm probably going the wrong way on these speeds. I should probably make this one be 1, and this one be 10, and this one be 15, something like that. Set. Oh, well, maybe 7. I'm just trying to be weirdly odd to make it. I don't know what we'll see. Oh, there we go. Yeah, that's some different stuff. So the view of some planet as seen from Earth is this complicated inner cycle weird loop thing, okay, that they've done over and over to try and make that more accurate. Okay. So that's really good. All right. But that's a good place to stop. So we'll pick up there tomorrow. I think I can clean up substantially. I mean, I'm going to eliminate pen circle, I'm pretty sure, and do that computation here, and see what else we can move around. Some of these aren't. Well, this one is really kind of independent. It's more about unit point and size than anything. But yeah, that'll be a good place. And well, thanks for joining. I had fun doing this. Kind of fast and loose sometimes, but we're getting a good result, I think. At least plausible, if not if not perfect. Anyway, tomorrow it'll be at 2 to 4:30 p.m. Eastern or 6 to 8:30 p.m. UTC. And we'll do a bit of cleanup and see where we can push this thing a little more. Thanks for joining. Bye-bye.